In this video lecture, we're going to discuss Kmap. What is Kmap? Basically, it's another way of simplifying our equation, our Boolean equation. Shucks. 1, 2, 3, 4, 5. In this video lecture, we're going to discuss Kmap. Kmap is another way of simplifying our Boolean equation. Another term for Kmap is Kmap, and it is a graphical method wherein we're going to plot the output of our equation or our truth table or our circuit in a matrix. We're going to write 0 in a box or 1 in a box. And then later on, we're going to group it to determine our SOP or POS simplified. So we have different sizes of our corner map. It could be either 2 by 2, 2 by 4, 4 by 2, 4 by 4. It is dependent on the number of variables. So for example, we have two variables in our equation. So we're going to use a 2 by 2 matrix, wherein one variable will represent the row, one variable will represent the column. In this example, Y will represent the row, while Z represent the column. And each row will represent the possible value of Y, and each column will represent the possible value of Z. So in this example, the first row means Y is equal to 0, while the second row means Y is equal to 1, while the first column represents 0 to Z and 1 to Z for the second column. So how we're going to determine how to plot the output of 1 or output of 0. Okay, so these values basically, these are our input. If the input is 0, 0, therefore we're going to plot the value or the output in this box. If it's 1, write 1 in this box. If it's 0, write 0 in this box. So if we have an input of 1, 1, and the result is 1, we're going to look for the box that has an input of 1 and 1. Y is 1, Z is 1, and then right here 1. So that's how we plot our output to our matrix. So later or in the succeeding slide, I'm going to discuss how to plot it further. Okay? So for a three variable Kmap, okay, so we're going to use 2 by 4 or 4 by 2, wherein one variable will represent our row and two variables will represent our column. So X, okay, first row is equal to 0 and second row equal to 1. And for the columns, we're going to represent it using YZ variable. And we could start with 0, 0, 0, 1, but when we are creating or when we are determining the values of our rows and columns, be sure there's only one bit change from one box to the next box, or from one column to the next column, or one row to the next row. Only one bit should change. So for example, 0, 0, next column, 0, 1, only one bit change. And then from the second column going to the third column, only one bit should change, which is the first bit. So 1, 1. And then on the fourth column, only one bit should change, therefore 1, 0. So don't forget that. So it should be 0, 0, 1, 1, 1, 1, 0. Okay, only one bit should change. But sir, there are some books start with 1, 1, 0, 1. It's okay as long as the next row or next column only one bit change. Okay, so this is a 3 variable Kmap. For a 4 variable Kmap, so 2 variables for your row, 2 variables for your column. So in this example, WX for row, YZ for the column. And the first row is 0, 0, second row 0, 1, third row 1, 1, fourth row, 1, 0. Again, only one bit should change from one row to the next row. And for the column, YZ, 0, 0, 0, 1 for the second column, 1, 1, and then 1, 0. Again, only one bit should change from one column to the next column to determine the values of each column or row in our Kmap. But in case if we have 5 variables, we're going to have 2 4x4, wherein one variable will have a value of 0, okay, for the whole 4x4 Kmap, and that variable will have a value of 1 on the whole Kmap on the second Kmap. Okay, so in this example, v is equal to 0 for this whole Kmap, and v is equal to 1 for the whole Kmap, for the second whole Kmap. And for Wx, same value 0, 0, 0, 1, 1, 1, and 1, 0. And Yz 0, 0, 0, 1, 1, 1, and 1, 0, same as with the second column. Okay, so as we increase the number of variables after 4 variables, we increase the number of 4 by 4. Okay, so 5, 2 of 4 by 4. How about 6? So it will be 4 of 4 by 4. How about 7? It will be, we're going to have 8 4 by 4. And if it's 7, 8, okay, if we have 8, we're going to have 16 variables, 16 4 by 4. So that's why for me, if we're going to have, if the variable exceeds 4, I'm going to go back with the Boolean algebra rather than using the Kmap.